Alright, good day everyone. This is the part 13 of the Dart series, that's from scratch for beginners that we're actually learning. And in this video, we'll be talking about bitwise operators and shift operators. Actually, we just need to touch it. That is it, because most of the time it's very rare for you to be writing bitwise if you are not writing a low level language, or you are building something in a very low level. What do I mean by low level? Maybe a compiler, or you are building an operating system, something that talks directly to the hardware, or that something that runs something. Probably if you are building, yeah, compiler, or you're writing your own programming language, yes, or you are building things that deal with graphics and the likes, something very in a low level language. And why do we call it low level? It's not because it's not because it's very it's low compared to status. No, we are talking about the closeness to the machine itself. What machine are we talking about? Our laptop, our mobile devices and the likes. That is it. But because it's part of the learning curve, we just have to touch it before we proceed to whatever else we still want to learn in this series. All right, without wasting much of our time, let's quickly get into it. Let's create a variable inside this, a file inside this bin folder. I just call it bitwise and shift operators dot that. All right, and it's still void. We are just printing, we are not returning anything. And bitwise, don't mind my AI, bitwise, and let me just do bitwise first before moving to shift. Bitwise operators. All right, bitwise operators, why we said is going to be much more like related to low level, is because of the machine level communication. That is what it is. Imagine when you say something like int, should we use 5? Yeah, we can use 5 actually. Int 5, and int a equals to 5. That's the variable. A is our variable and we're storing 5 inside it. And int b equals to 3. Oh my goodness, this AI will not kill me actually, but don't mind me. I've said it earlier in one of my video. If you watch and you feel like it's not making sense, I should disable the AI. Definitely I'm going to disable it so that we can learn on our own actually. All right, before proceeding, let me just comment this bad boy out. All right, we have int. We already learned data type, we learned variable, we learned the assignment operator, then we learned our data that we're storing there. All right, we are storing 5 inside A, we are storing 3 inside B. If you are from a computer science background, you learn computer science from school, definitely you're going to know what is called binary. Binary is 1 and is 0, true or false. That is what binary is. And binary is the machine language. Yes, that is the first language. When in back then, in the olden days, I am not there actually, but I actually learned it from school, where it was told, and you still learn it, and that's how it is actually. Computer is being communicated with binary, with this 1 and 0. Yes, there's a way we end up in this. You don't just think it here. There's a way we end up in the calculation of the binary, whereby we're able to compute every single alphabet, every single characters. You'll be able to convert it to binary, and you'll be able to input it to the machine, and the machine is going to give you the result. But it is a very tedious and difficult time to make use of computer. Imagine all what I'm saying, all what I'm typing, I have to firstly convert it to binary before I can give it to the computer, before computer can process. You can see that it's a very long process. Seriously, over time, computer has actually improved. We are now in a modern age of computer whereby we now have AI, whereby you can even be talking to AI like a human being. Like you can be talking to computer like a human being, and it's going to be understand. It's computing the behind the scenes, computing the one and the zero for every programming language. Actually, that's why we have the compiler and the interpreter. Yeah, it's going to. This is actually a compiler, is a compilation language. That is actually a compilation language. It's going to compile and run your code and give it to the machine, which is the laptop, to understand everything that is going, all the things that you're saying on the terminal. Firstly, go through one and a zero before coming to your terminal as a meaningful result. All right, that's short. I can explain on that for you. We can proceed, and you can see 5 is 0 1 is 0 1. If you convert it normal, if you learn it and convert it, it's going to give you 0 1 0 1. Then 3 is 0 0 1 1. That's it, binary. And that's why I said this is, you are not going to be using it too much, like this bitwise operators actually. All right, if you are bitwising days, which we call and bitwise, if you are bitwising days, it's going to give you 0. Yeah, it's going to give you 1, and 1 is 0 0 0 1. Yeah, that is what is going to actually give you, because bits and this and bits actually is going to move everything you are doing, is going to move it to 1. That is how it works. When you are hand bitwising, everything you are handing together, even if it is 50 30 50 now, this is going to change actually. When you bitwise this, definitely it's going to give you whatever binary equivalent is. And when you bitwise these two, there's a calculation for the bitwise also in if you want me to bring the calculation for you, actually we can bring the calculation and calculate it. It's going to give you 10, and 10 is 1010. And let's run. Have I saved? Let me save. Clear. And we can say that is running bin, and we have bitwise and shift. There's a rule behind all this operation, how it works actually. It says it can't find the file. I think I've put hyphen here. Oh, that's gone. You can see it gives you 1010. That is the bitwise operation, which is 10 in the binary state, which that's what we actually want to learn. But when you run it, it gives you 8 to outside. That's why we told you that you are not going to be using it so much in your application than using it in a machine level process, because a machine level process, it doesn't need this normal human being output. It only need this 1 and 0 that we are talking about. All right, and it actually depends on machine also. That's another thing. All right, let's do 6, and let's do 3, and let's bitwise it and see what it gives us. 4. It gives us 4. Yes, it gives us 4. Correct. All right, you can bitwise, or let's speed this up actually. If you want me to bring out this is actually working, we can do the whiteboard animation, or I can do everything, I'm going to make use of a camera. I'll show the workings through pen and book, and we can use the whiteboard normally, go on the whiteboard and explain to you much better than what computer is computed for us. And we can have this also. This is 6, and we can clear. Let's clear. We are running on that should give us 6. Oh, beautiful. Then we have this also. This is called XOR. This is AND. This is OR. This is XOR. All right, XOR is a bit that you can see that we're talking about bits because that's the smallest unit. Is a bit that differs between the two. The first one is a bit that are one in between the two. Then the second one, which is this OR, is a bit that are one either. It's either this is this is both, return 1 if both bits are 1. That's what it means. This is for both, yes. And return 1 if at least one, that is either at least one is, sorry, at least if one is 1, if one of the variable is actually 1. Then this one, return 1 if the bits are different, if both of the bits are actually different. Then the number of 1 that is being returned is what is going to sum and return us back to this value that you're actually seeing. And this is, I can say both, and this one is either, and this one not difference. All right, yeah, we're going to get to not, but all right, apologies for this actually. Okay, this one is difference, which is the difference. Return 1 if bits are different. The bits inside the two variable, these 2 bits, if these 2 bits are, sorry, if these 2 bits are actually, if the differences between them are actually 1, then it should now return the 1. That is it. Then the last one is this coily symbol actually, and is meant for invert, like the opposite, like reversing it. That is what it is. And let's run this and see. All right, okay, this is difference here. We talk about difference already. That is 2, and this is the inverse. All right, let's talk about the shift operators, and we can use the same variable. We just need to print, sorry, we just need to shift. We can shift 1 inside this, and we can shift 1 out of this. And what the shift is actually all about, the shift bit left, this one shift inside, the one greater than double greater than shift inside, then the double, sorry, the double less than shift inside, then the double greater than actually shift outside. That is it. Then when the shift actually happens, what actually happens, effective multiplied by 2 is actually, it asks to multiply it by 2. Whatever happens, it multiply it by 2. When the shift happens, it multiply it by 2, and that is what the shift actually means. And let's clear, let's see. 1 should give us 12, 1 should give us 3 actually. That is it. What is there is that the calculation is going to be done in bits, binaries, and converted to decimal. You know that all these are decimal. Base 10, or what computer understand is base 2. Base 2 is binary, and base 10 is 10. Yeah, actually base 10. Okay, I think that is all about this video. But I think I want to round up this table of contents. There are some things that was missing in some of the last video, just like a revision. We have operators. There's the place we're actually doing arithmetic operators. Yeah, the year. Oh, don't let us clear this. Let's just create another um revision. Let's call it revision. You can say arithmetic extension dot operators extension is fine. That's all right. So you can do void, you can do main and save. We can, what we want to do is we just want to teach, we have something called operator precedence, and what it means is how do computer actually do precedence, like how does he join it together. In this case, for example, now is he going to firstly plus 5 plus 3, or before it multiply with 2, or will he firstly multiply 3 times 2 before it plus it with 5? That is what we call precedence. How do you want the calculation to actually get solved? If we run this guy now, let's see and see what it actually does. Is run, that is that run bin slash arithmetic extension dot, I think extension is actually S, but we use T. Okay, let's continue it like that. All right, you see that we have 11, and what does it does? It says 5 plus 3. 5 plus 3 is 8. 8 plus 2. 8 plus 2 is 10, which is, that's not what it does. What it does is 3 times 2, that is 6. 6 plus 5, that is 11. That's how it's able to get 11. And in things like this, the precedence, most of the time, how we line it in mathematics is BEDMAS. We call it BEDMAS. Yes, that is this is how precedence actually work, from the bracket to the exponential to the division or multiplication. You can see it took the multiplication before the addition and subtraction. That's what we call BEDMAS. That's it. I think in mathematics we call it BODMAS, of is multiplication, but here we call it BEDMAS. Exponential is like having multiple of it. I think let me check this table again if we have anything we've not actually covered in this series. Okay, let's check assert. All right, let's check assert. Just want to rush it up. New file, assert, assert function. It's a function actually. We just need to touch it, and we can have void, and we can have main, and we can have assert function. All right, this is assert function. It works like if statement. Actually, it's a boolean check. If we get to if, we are going to see this, but because we've learned ternary operator, and we've learned logical operation. Also, we've learned comparison. You see some of it in comparison, you see some of it in logical, other things. Actually, because we've learned the comparison, we quickly want to chip in this. This is going to actually, the two things that is going to get done here is it check if it is it, and if it is not, it's going to print the result out for us. And we can say, we say that run, we have assert underscore function dot that, and it's going to run that for us. All right, it's check if age is greater than. But after checking, there's one more thing we need to do. We need to print age cannot be negative. Yeah, we can print anything actually. You can say age, yeah, age is greater than 0. Yeah, simple. What's going on with my ID? I don't understand. This ID is, this AI is smoking somehow. Come on, get out. Okay, thank you. Let's quickly run this. We are running out of time, and I want us to cover the syllabus. Okay. Yeah, it's greater than, that's why it's not actually failing. Then is it less than? Let's check for this. Also, it should actually print, but it should throw an error, but it's not. I don't know the reason why it's not throwing error for us. It should actually throw error. But let's see, let's use negative. Okay, it's been long and use this assert actually. I don't know, it's not throwing the error. It should actually throw error if anything goes wrong and tell us what actually goes wrong. But I think most cases, most of the time that I've been using this assert, I think is in PHP. Yeah, it's in PHP. We use it to write tests. That is it. I think that will be all for this tutorial. Let me know in the comment section if you are actually able to get this assert resolved. That is it. Thank you.